All right, so we have been solving systems of equations. We're going to take a break from that today. We're going to talk about something else, and then we're going to pull it all together next week. Review Thursday, test, our quiz coming up Friday, not a test yet. So first off, we've talked about this. How can you tell if an ordered pair is a solution to an inequality? What do you do with the point? Plug it in. So we'll just do one of these, not going to do all four of them. Remember, it is always x comma y, so I put the x in for x, the y in for y, and then you evaluate. So 5 times -4 minus 2 times -1. And by now you may have noticed there's a slight change with what we're doing. We have inequalities in our problems today. So -20 plus 2 -18 is -18 less than or equal to -1. Yeah, much less. So, true, yes. When we had an equal sign, we had to get an equal. It had to become the same number. But obviously with an inequality, we have a whole range of things that will be equivalent or will be true today. So, how can you tell if a solution, you plug it in? Well, what if I don't give you the point? You're going to have to graph a line, and now we're going to be graphing inequalities. So how do you graph an inequality? Well, you graph the boundary line. What do you mean boundary line? Well, you'll see. It's just the line. Nothing's fancy, but it's called a boundary line here. And then, this is important to note, make sure you're writing this in your notes. The boundary line is dashed if you have a less than or greater than sign, and the boundary line is solid if you have less than or equal or greater than or equal. Okay, so that's an important difference from what we've been doing. And then you test a point. And we're going to talk about how you can test a point, and we're going to talk about a little faster way to do it. Determine whether it is a solution. So you test a point. So basically, you're doing this a lot. We'll talk about easy ways to do it. All right. When a point is a solution, that side is the true side. If you find one true point, every point on that side is true. So we'll do some explanation here. All right. So there is our equation. So first off, I need to graph this line, but it's got the greater than sign. So when you're graphing the line, ignore the greater than sign. Okay. So I need to graph this. What form is it in? It's in standard form. What method works best with standard form? Hopefully you're thinking about intercepts, but I know most of you don't think about intercepts, but hopefully you are, because it is the easiest one. So if I want to graph this with intercepts, I put 0. So if I want to find the x, intercept, where do I put 0? For y. So if I put 0 for y, I get negative x equals 2, x equals -2. So if I'm graphing this, my x-intercept is -2. And then, if I want to find the y-intercept, where do I put 0? For x. So then I have 2y equals 2. My y-intercept is +1. Okay? So now I have my boundary line. It's right through there. But it's important to think before you draw your boundary line. Is this a greater than or equal, less than or equal, greater than or less than? All right? Remember, we use a dashed line if there's no equal sign. We use a solid line if there is. So, what kind of line am I going to put here? Dashed. Dashed line. All right? Now, all that nonsense, all that stuff about a test point. Since this is an inequality for real, one of these sides of this line is always true and the other side is always false. You need to figure out which side is which. So you pick a point on one side or the other. Doesn't matter which side you pick. Okay? You're not trying to guess which one's true. You're just trying to guess. Okay? Just trying to pick a point. I'm going to let you in on a little secret. Think about it for 1 second. What's the easiest point to plug in? Hopefully you said 0, 0. If your line does not go through the origin, now if it goes through the origin, you can't use 0, 0, because you can't use a point that's on the line. But right here, right there is 0, 0. Plug in 0, 0 into your equation, just like we did in the beginning. Put in 0 plus 2 times 0. 0 plus 0 is greater than 2. Is 0 greater than 2? No, 0 is not greater than 2. So this is false. 0, 0 is false. Most kids, everything we've done up until now, you can figure out pretty easy. This next concept is very difficult for some kids. If this point is false, that automatically means that every coordinate point on this side is false. And it means that every point on this side of the line is true. So, if this side is the false side, that's the true side. You shade the true side of the line. That is shaded in. Okay. Let's do this again. Oh, what if we have, what kind of line is it? What kind of line is that? We'll just go ahead. Horizontal line at 2, right? Is it going to be a solid line or a dashed line? Remember, if you don't remember, look back at your notes. That is a solid line at positive 2. So now I still need to shade one side of the line or other, all right? So there's no real test points here. You just kind of got to think, y is less than or equal to. Well, where's the points less than 2 on the y's? Well, down here, all the negatives on that. So less than is that one. Okay, little common sense. If we got a vertical line, okay, then you got to use some common sense, less than or equal. We don't really use test points on the horizontals and verticals. All right, so not gonna mess with those. Let's talk about these down here. If I'm gonna graph this, I could graph with intercepts, or we didn't talk about this a second ago. I can graph with y equals. So let's back up a second. Before we tackle these, let's flip back to our previous problem. All right, so this was our graph. We had this graph, we shaded above. I want to show you something. What if I get y by itself and get it into y equals 4? Okay, some of you like that, some of you don't. Just follow along for a second. So if I'm going to do that, I'm going to add x to both sides. I'm going to divide everything by 2. And then I'm going to graph this. What's my y-intercept? What's my slope? Up 1, right 2. Look at the previous graph, the one we already did. It's the same line. Well, it should be. We did the work. Is it solid or dashed? Well, we know it's a dashed line. That didn't change. Okay. When you do this work, if you're going to do this, keep the inequality in the problem, and I'll show you why. Everything's too big. So it was a greater than sign. We divided by 2, it's still a greater than sign. Which side of the line was shaded original? Up above. What kind of sign is that? Greater than. We shaded above the line, and it's a greater than sign. If you use y-intercept method. This sign will tell you where to shade. If it's a greater than sign, you shade above. If it's a less than sign, you shade below. The reason I mention all that, let's say we get to a problem here like number 8. Let's get it in y equals 4. What am I going to divide by? What happens when you divide by a negative number? Flip the inequality. So that's why I say keep the inequality in if you're going to do this method, okay? The inequality turns around. I get 1/2 x. Now I can graph this. My y-intercept is 0. I don't need to worry about it because I'm not doing test points. My slope is 1/2. Up 1, right 2. Is it solid or dotted? Am I shading above the line or below the line? Well, I have a greater than sign now. Doesn't matter what it started as. I have a greater than sign now because I divided by a negative, I flipped it. So I'm shading above the line. I like using y-intercept form for this because of that part right there. You don't have to do the test point part. You just shade above or shade below. That's going to come in real handy to next week when we do a little bit more with this, okay? When I do these on, for examples, I will be getting everything in y equals form for graphing made easier, a little faster, okay? So let's do one more together. Get y by itself. That gives me so now I graph my y-intercept, -4, my slope, -1, down 1, right 1, solid or dotted, solid line, shade above or shade below, less than or equal, less than is below, below the line, shade below the line. There you go. All right. There you go. We talked about horizontals, verticals. Get them in y equals form. It makes the shading a whole lot easier. It makes the graphing a whole lot quicker. Pay attention to solid lines versus dotted lines. There you go, boys and girls. Quiz coming up.